In this lecture, we're going to look at how bits can be used in storing game data. Now, you probably already think, gee, everything in a computer is stored in bits, which is true, but instead of the way that you might be used to storing game states and information in individual data types such as ints or floats, I'm going to show you how you can make the most of computer memory by processing the bits and jamming them into just one value. For example, let's say we want to store an RPG character's attribute set, which could include any combination or even all of the following: magical, intelligent, charismatic, flying, and invisible. And for this example, we only care if the character has the attribute or not the strength or value related to the attribute. How might you store these? Well, there's a number of ways. You might be inclined to do something like this, where each of those values is assigned to a Boolean, and the Boolean can then be set to true or false based on whether your character has that attribute or not. A bool in C# is stored in 1 byte or 8 bits. It's the smallest data type you can have access to. If you could create bit-sized pieces and put values of 1 or 0 in them to represent true or false, you might not be guaranteed they are efficiently packed together in memory, not like an array is. If you have this or something similar, then to test if a character has an attribute or not, or even a combination of attributes, you need to do some code that looks like this. If has magic and has intelligence, and they're both true, then you can run learn spell. However, what if you are able to store each attribute in a single bit? This is where our integer in binary format comes in. Consider each box in the integer to represent one of the attributes of the character. If the character has an attribute, the associated box is set to 1. Otherwise, it is set to 0. To replace the declaration and setting of the 5 bools here on the screen, we could instead use a single integer with the binary sequence 10100. Bit values used in this way to represent a multitude of values are called bit flags. This binary number represents 20, so we could declare this character to have magic and charisma with int attributes equals 20. Or, as we saw in the previous lecture, int attributes equals 16, which represents magic, plus 4, which represents charisma. But an easier way is to work in powers of 2 and declare the individual attributes to have their own values like this, where we can create a bunch of static ints representing each of the flags. Now, to set the attributes property with the differing type of abilities, we can simply add together the values for the ones we want, like this. Each power of 2 will place a 1 in the relevant column of the integer, setting the flag. Now, you might be thinking that instead of reducing the memory needed to store the initial bools, we've actually increased it. However, if we've more than one character, each can have a single integer that represents all of those attributes. So over many characters, we actually start to save space. But this is not the only benefit of working with bits like this. Enter bitwise operators. Just like we have the Boolean operators and, or, XOR, and not in programming, we also have an equivalent set that work at the bit level. The bitwise AND operation runs a Boolean AND at the bit level on the individual bits in a binary sequence. It performs AND operations with the 1s and 0s in the same columns to produce a new binary number. For example, if we AND 1011 and 0011, then we AND each individual column of bits. So the rightmost column, 1 and 1, will give us a 1. The next, 1 and 1 will give us a 1. 0 and 0 will give us a 0, and 1 and 0 will give us a 0. It's exactly the same rule that you use for working out the AND between two Boolean values, such as true and false, where in this case, 1 would be true and 0 would be false. Try working this one out for yourself. How did you go? Did you get 1001? Notice the only time you will end up with a 1 is when both of the other two bits are set to 1. The bitwise OR operation combines the individual bits with an OR operator. In this case, we're going to perform the operation 1001 or 111. Again, working from right to left, we're going to get 1 or 1 gives us 1, 0 or 1 gives us 1, 0 or 1 gives us 1, and 1 or 1 gives us 1. You can start to see how it's very similar to the Boolean OR operator. Try working this one out. Did you get 1101? The bitwise XOR or exclusive OR combines the two values. It will only ever give you a true if only one of the values being compared is true. Otherwise, you get a false. In this example, working from right to left, 1 XOR 1 is 0, 1 XOR 0 is 1 because there's only 1 XOR 1 is 0, and 1 XOR 1 is 0. Try this one out for yourself. How did you go? Did you get 0, 1, 1, 1? And finally, we have the not bitwise operator, which simply switches the bit value to the other one. So for 1010, working again from right to left, 0 becomes 1, 1 becomes 0, 0 becomes 1, and 1 becomes 0. Try this one out for yourself. How did you go with that? Did you get 0001? We can use bitwise operators for manipulating and testing the flags in a binary sequence. Remember our example from before for setting a character's attributes? Well, in the previous setting of our attribute, we were assigning a decimal value or using the addition of powers of two values. Instead, we can use the bitwise operator OR to combine the values thus. And if we quickly work this out in our head, then we can add magic, which is 10000, and charisma, which is 00100, to give us the binary value 10100 when they're ORed together. And this binary value, when you translate it back into decimal, gives you the value of 20. Now you're probably looking at this wondering, do I use addition or do I use the bitwise OR for combining these values? Well, the answer is you could actually use either one of them. None is faster than the other in this particular case. Bitwise operators are faster than multiplication and division operators, but not addition and subtraction. So when setting your flags, it doesn't really matter which one you use. Now let's say your character already has magic and charisma, but you want to add intelligence. This is easily done with the OR equals operator like this. To unset a flag, the bitwise AND in combination with a NOT can be used. To take magic away from our character, it's a matter of performing a bitwise AND between attributes and the NOT of magic. Let's take a look at this in action. So the initial setting of the attributes for magic and charisma give us 10100. We then can add intelligence, giving us 11100. Now, not magic would be 01111. And when we AND not magic with what's already in attributes, then we end up with 01100, where magic has been removed and there's only intelligence and charisma left. Now, there's nothing like learning this than to put it into actual practice. So what I'd like you to do is create a new Unity 3D project and bring in the package that's attached as a resource to this lecture. When you open up the bit settings scene, you're going to find something like this. So you'll have a third person character, and if we press play, she will be able to run around and the camera will follow her. Now you'll see that she's also got a text box which is nicely added onto the character and positioned just below. And this is the text box that we'll be using to show what attributes the character is picking up. So we're going to work with the same lot of attributes we've just been looking at, such as like magic and charisma and intelligence, and we're going to play around with turning them on and off. Now, so that we know what's on and off, we're just going to print out that binary string under here in the attributes that you can see on the screen. Alright, so just a quick overview of what's going on in this scene. There's a cube, and it has the magic texture put on it. And if you go into the textures folder I've supplied, you'll see that there's textures for all of the other attributes that we'll get to using a little later. Now this attributes text that you can see on the screen, it's a text box on the canvas. Now it's assigned to Combat Jane, our character, via the script. Now if we go back into assets, our main script that we're going to be working with is called this attribute manager. That's attached to our character right down the bottom, and you can see that the text is passed through so that we can set the string value on that, and also so that we can position it as the character moves around. Alright, so first of all, let's have a look at what's going on inside our script and where we're up to. So it's very simple what I've got right now. So we're going to pass through our text that's on the screen, then we're going to work out its screen coordinates based on the character's world coordinates, which we do with this line here. So we actually convert the character's position using world to screen point. That gives us a point on the screen, and then we can position that text box at that point plus a little bit more, so down in the Y direction, so it kind of sits just below her feet as she's walking around. Alright, so let's go ahead and actually put some attributes in and display them. So at the top here we want to declare our attributes. Now we're going to use an integer for the attributes, so that's going to be 32 bits long. We don't even need that many. I mean, we're only working with, what, 5? So, but anyway, that's enough for now. We'll just leave it. It's easier. So attributes, and let's set it to be 0, like that. So there's no attributes whatsoever at the moment. Now what we're going to do is to print what is in these attributes in the binary form into this text box. Now we'll do that in update so that as the attributes change, they will constantly be written into that text box. So in the update, we're going to go attribute display dot text to access the string equals convert dot to string that we used before, and then attributes as a power of 2. And we're also going to pad this so that we can see all of the string, and we'll just show the first 8 bits, or at least the rightmost 8 bits. Okay, so we're going to pad left with, let's say, 8, and we will put zeros in there. Now this convert, remember we need the library for system at the top, so using system. Right, now just save that. Now when we go back into Unity and we press play, you'll want to see what your attributes now say, which should be all zeros, and you can see them down in there. Now if you're having difficulty seeing this string, you could put it further down in the Y direction with that new vector that I've got in there. The other thing is you could change the color of it. Let me quickly show you how you do that. Over on the canvas text, in the inspector, if you look down for text itself and just go down here, you'll see that there is a color field where you can set the color. So just change that, and that will change the color of that text that's showing up. Alright, so let's just check if we change that text now to attributes. If we set the attributes to 1, then we should get 7 zeros with a 1 on the end. Save it, switch back to Unity and press play. Now, if I just move out of the shadow, we can see that that's working quite nicely as far as displaying our binary sequence that we're working with. Now, what we're going to program this to do is that when the character runs into this block, that she's going to have the magic attribute set for her. Now, if you remember back earlier in this lecture where we defined the values for each of those, magic was going to be a value of 16. So we can actually put that into our code. So let's open up our code. Above where we've got the attributes, first of all, let's just set that to 0. And then we're going to put this right at the top so that we can find it. We're going to make a static public int, and we will call this, let's just call it magic. It's easy. Equals 16, like that. Now, with our attributes set to 0, the next thing we've got to do to set magic is actually run into that box. So let's just save and zip back over to Unity for a second. Grab hold of the purple cube that's in there. So it's the magic cube or door or whatever you want to look at it like. We're going to tag it so that we know that we've run into it. Over in the inspector under tags, you want to drop that down and add a new tag. And in here, we're going to add a tag and call it magic. And I'll do them all in capital letters so that we are consistent. Save that, switch back and click on that cube again, and then set the magic tag so that it says that up there. The other thing you're going to have to do is find the box collider, and for the is trigger, tick that box. I already ticked mine, but you'll need to tick it. That'll make the collider so that she can actually walk through it, and it will then trigger an event for us. Now that event is back in our code, so we will open up our code, and what we're going to do above that start function is write an on trigger entering one. So void on trigger enter, and then that's going to tell this script what you actually ran into. So in here we can put if other.gameObject.tag equals magic, then we know we've run into that magic tag. And at this point is where we can set our attributes. So do you remember how to add a value into your attributes? We use attributes bitwise or equals magic. And therefore you can do more bitwise or equals with anything else when you run into those sorts of objects to keep adding them to your string of attributes. When we've run into that door, we should be able to see the attribute string change on the screen. So save that, and we will go back to Unity. We're going to press play and walk through that cube and see our attributes change. So our attributes are 0, 0, 0. We've got nothing, and we will turn around and run through the door, and you can see there that it's not very clear on my screen. If I keep running around, you'll be able to see that string. You can see that the 16 box for the bits is now set to 1 for magic. Okay, so I hope you didn't find that too difficult or taxing. So what I'd like you to do now for a challenge is to add all of the other doors. So you want to have a door for each of the other values, which has a texture in here for charisma, fly, intelligence, according to what we set them for way back earlier in the lecture, and have them all change her attribute binary string according to which ones she's walked through. When you come back in the next video, I'll show you how to do it.